In this video we're going to look at simplifying algebraic fractions where we need to factorise the numerator and the denominator first. So let's have a look at this first example here. So we've got 3x plus 6 at the top. Now there's a checklist I'm always going to go through first. I'm going to just check, one, is there a common factor? And in this case, yes, 3 is a common factor to both these, so let's take that out. That gives me 3, a set of brackets, and then if I divide these by 3, or say what do I multiply by 3 to get 3x, I multiply it by x, and what do I multiply 3 by to get 6, well I multiply it by positive 2, and that's the top then fully factorised. If I then put on the bottom part and again go through my checklist, 1, is there a common factor? The answer is no. 2, is it a difference of squares? Again, the answer is no. And 3, a trinomial. Well, this at the bottom here is a trinomial, so I need a factor pair of 6 with a difference of 1. So two numbers that multiply to get 6 and have a difference of 1. So the factor pairs of 6 are 1 times 6 and 2 times 3. The ones that have a difference of 1 are the 2 and the 3, so we can put them into our brackets, x and x for my x squared, my 2 and my 3. And remember here, my target number is to make this negative 1x here. So what I'm going to do is negative 1x will be negative 3 plus 2. That's what's going to give me the negative 1. Now, like when we just simplified algebraic fractions that didn't require factorising, what we've got then is we've got this 3 is multiplying this, and this x plus 2 is multiplying this bracket here. So now it's a multiplication at the top and a multiplication at the bottom. I can start to cancel by dividing top and bottom. Now what they both have in common is they have this x plus 2 and this x plus 2, so they can therefore be cancelled. Now remember what's actually happening here is I'm dividing the top by x plus 2 and I'm dividing the bottom by x plus 2, so these would leave behind these little residual 1s. But we can just write that as 3 over x minus 3, that's what's left over there. And that's it fully simplified. We'll do the same for the next one. We'll have a look at the top part here, 1 minus x squared. So 1, is there a common factor? The answer is no. 2, is it a difference of squares? Yes. So 1 minus x squared, that's going to be a difference of squares here. The square root of 1 is 1, so 1 and 1. The square root of x squared is x and x, so we can put them in there. And difference of squares gets 1 plus and 1 minus. For the next one, we're going to again check, is there a common factor? And the answer is no. Is this a difference of squares? And again, the answer is no. And then 3, is it a trinomial? Okay, so this is a trinomial at the bottom. So looking through this, I need a factor pair of 3 with a difference of 2. So I've written out my factor pairs of 3 here. It's 1 times 3, and that's the only one. It also has a difference of 2, so that's quite handy. So x and x for my x squared. And I'm going to put my factor pairs of 1 and 3 in. Now here my target this time is going to be negative 2. And again we're using these numbers here. So that's negative 2 using 1 and 3. So it's going to be positive 1, take away 3 to get this negative 2. So put the plus in front of the 1 and the minus in front of the 3. Now again, what we're looking to do is find brackets which are alike here. We can cancel. Be careful with this because obviously 1 plus x and x plus 1, they are the same. They look different, but both of them are basically the same as x plus 1. So they can be cancelled. And then what I'm left with is this and this. So I'm just going to write that as a single fraction now. So it's 1 minus x over x minus 3. And that again is it fully simplified. Look at one last example here. We've got 2x squared plus 5x minus 3 over x plus 3. So we'll start with the top one and we'll go through our checklist. 1, is there a common factor? And that's worth checking because I've got 2 here, but none of these are divisible by 2, so no. Is it a difference of squares? And again, the answer is no. Is it a trinomial? Yes. Now this is the slightly harder trinomial because it's got this number in front of the x squared term. It's not just 1. So remember, I need a factor pair of 3 where inner and outer products have a difference of 5x. So I'm going to write that out. So let's have a look at the parts of that. So I need a factor pair of 3, which is 1 and 3. And what I want is the inner and outer products to come to a difference of 5x. Now, we've got a 2x at the front here, so I'm going to put 2x times x is the only way I can make that. And I'm going to pop my 1 and 3 in just any way around. Now, my inner product here is 1x, and my outer product is 6x, and they do have a difference of 5x, so these are now in the right place as well, which was fortunate. My target number is this positive 5x here, So with this 1x and 6x, I need to make positive 5x. So I'm going to make this positive 6x here. And I'm going to take away 1x from that, so it's going to be minus 1 times x. And that's it, fully factorised. So we're going to just put it up here now. We've done our bit of working at the side. So 2x minus 1 and x plus 3. At the bottom, we're going to run through the checklist. We'll just do it mentally this time. We've got, is there a common factor? No. Is it a difference of squares? No. Is it a trinomial? No. This basically can't be factorised any further, so it's just going to remain as x plus 3. Now, what we've got at the top and the bottom, we do have two things which are the same, so we can cancel them. What to remember is, just like before, when I cancel everything off the bottom of a fraction, the fraction no longer needs to be there. So what I'm going to be left with is this 2x minus 1, and that's basically it. When I divide top and bottom by x plus 3, they would each leave behind a little 1, but we don't divide by 1, or we don't write that we're dividing by 1 because it's not necessary, so we can leave our answer like that. Had the fraction come out, just worth noting that if the question had been slightly different, and say it had been the other way around, where we have x plus 3 over 2x squared plus 5x minus 3. Now the factorising would still be the same, so it would still be just x plus 3, that would stay as it is, and the bottom part would be the 2x minus 1 and the x plus 3, just exactly the same as it was up here, just these two are the other way around. When I cancel this case, x plus 3 and x plus 3, remember they leave behind these little 1s, because what I'm actually doing is dividing both top and bottom. So this would come out slightly differently in that we would need to leave it as a fraction with a 1 at the top, and that's worth just remembering that. So it would be 1 over 2x minus 1 rather than just 2x minus 1. So if those were reversed at the start, that would give us a different result, and it's worth being aware of that. Now I'm going to give you a chance to try 2 of these yourself. So pause the video here and then press play after each one to go over and check your answers. Okay, first question here, we need to factorise the top and bottom, so we're going to go through our checklist. Is there a common factor? No. Is there a difference of squares? Yes, that top one is a difference of squares. So we're going to put it in as the square root of x squared is x, so x and x. The square root of 9 is 3, so 3 and 3, and 1 plus and 1 minus. At the bottom here, we have to go through the checklist again. Is there a common factor? No. Is there a difference of squares? No. Is it a trinomial? Yes. And in this case, I'm looking for what you should have written down is a factor pair of 9 with a sum of 6. So factor pair of 9, let's put them up at the top. It's 1 times 9 or 3 times 3. That's the one that has the sum of 6. So I'm going to put those in here and here, 3 and 3, x and x. And my target here is to make positive 6 using my 3 and my 3. So it's going to be positive 3 plus another 3. What we then do is we cancel like values. So x plus 3 and x plus 3 can cancel. And we're left with then just x minus 3 at the top and x plus 3 at the bottom. For the next example, we'll look at the same sort of process. We'll go through our checklist at the top here for factorising. So is there a common factor? Yes, x is a common factor, so we can bring that out and have it at the start of an empty bracket. What do I multiply x by to get x squared? I multiply it by x. What do I multiply x by to turn it into 4x? Well, I'll multiply it by positive 4. And then I get to the bottom, and again, I can look at that. It's probably quite clear that doesn't factorise any further, but if in doubt, just go through your checklist. Is there a common factor? No. Is it a difference of squares? No. Is it a trinomial? No. So that's it, actually already fully factorised there. Now when I cancel here, this one's slightly different, remember. Because I'm cancelling this x plus 4 and this x plus 4, because I've cancelled everything off the bottom here, then it would leave behind a little 1, so I'd just be left with x over 1. But remember, I would just write that as x, the fraction would disappear.